there. All right, ratios and proportions. Remember this. Do we remember what a ratio is? Do we remember what a ratio is? No. Yes. So I don't know, guys, no, this is a lesson. More eyes are front, even though I'm back here. So is this what you think of a ratio? The comparison of two numbers using division. Does that make sense?
Yes.
Does it? I don't know. Using division, what do I mean by using division? Give me an example of a ratio. 3 to 4. So how is that using division? 3 out of 4. I could almost write that as a 0.75. Now we don't. We write ratios as a fraction so we can see what the comparison is. But I could divide them and say the ratio is 0.75. I could. We don't usually, but we could. So it is, we're using division. How do you write them? And he gave us an example. A to B. A with the colon B, that also means A to B. Or A over B, which is that division. They all mean the same thing. I'm comparing A to B. That little note B is not 0. Why do I need that little note B is not 0? Why is that, Thomas? Right. You can't divide by 0. That's undefined in mathematics, so we just put that little note there. When I write a ratio, it's always in simplest form. So I have 6 dogs to 10 cats. That would not be 6 to 10. We would write that as 3 dogs. Cool. Okay. Simplest form always. Some examples here. So what is the ratio of boys to girls in this room? Oh, goodness. Somebody tell me, because I don't know. Boys to girls. Not 50 to 1. 1, 2, 3, 4, 1. Where do you get 1? How many boys? There's a girl. Oh, what? Oh, okay. I thought you were looking at Connor saying you've done it. Hello? I don't think so. So 13 girls. How many boys? No, I've got 1 boy outside. How many boys do we have?
11.
14 to 12, is that? Well, somebody was absent, right?
12. There's 12.
Although we got a problem, because I know I got 27 kids in this class. So something's happening. All right, well, I'm getting 14 to 12. So the first number is boys, is that right? Okay. Well, let's see if we can figure this out. How many boys? 12. How many girls? So I have this backwards? Is that better? Okay, so I have to have, has to go in the same order that you're ready. Say boys to girls, those numbers have to work that way. Can I leave it like that? Now what should it be? Right, we have to put it in simplest form. So divide by 2. Oops. So that's how we do it. I don't need to fill that in. So yes, we remember that. That was what, 5th grade, 6th grade? When did we do that? I don't even know. But a long time ago. That's a ratio. So now we're kind of working with triangles. The ratio of a side length in triangle ABC to a side length in triangle EDF. Well, what is it? So I'm looking over here. Here's ABC. So they have to match. So AB and DE would be corresponding sides. So 2, is it this good? No. I was hoping it was working. So 2 to 1, 2 to 1, 2 to 1. Am I noticing anything? Let me see. Take this one. I actually cheat it here. 2 to 1. The ratio of width to length in RSTU. So width to length, which is the width? ST, right? And which is the length? So what's my ratio? What? What's my ratio? I want to go width to length. What is it? 1 to 2? How'd you get that? Right. Now what happened to units? You know, we're really thinking about units. Where do I have to say 7 feet or 14 feet? Why don't I? How come we don't? We don't. Yeah? It's a ratio. And what happens now, if you think of, I like to think of units in Fort Worth, right? I could say feet over feet. 7 feet to 14 feet. The units themselves are almost like the variables. Feet over feet, don't they cancel out? It's like x over x, they become a 1. So if you treat the units almost like another variable, you see them canceling out. So ratios generally don't have units. They're just, one is twice as big as the other. That's all we need to say here. What's my last little point back here? Get my exercise today. Always put ratios in simplest form. Good. All right, extended ratios. These can compare more than just two numbers. So the ratio of the sides of a triangle is 4 to 5 to 8. Find the length of a side of a triangle with side lengths ratio 4, 5 to 8 if the perimeter of the triangle is 204. What? So let's see. I think I do have answers here. So let's see if we can talk to those. I wish I had a picture. Oh, let's see. Can I draw a picture freehand? I doubt it. All right, I'm just going to make a little triangle if I can. It's not going to let me. Come on. Make a triangle. Wow, that's a really wacky triangle. Let's make a different one. Okay, so if I have a triangle here, if I look at the different angles, 4 to 5 to 8. So one of them is 4 times the other. One of them is 5 times the other. And one of them is 8 times the other. So we set up a picture like this. And what this tells us is, look at the angles. They're in that ratio of 4 to 5 to 8. Now, I don't know exactly what they are. It could be, if x is 2, I might have 8 to 10 to 16, right? I don't know. I don't know exactly the scale factor of them. So I set them up with x. What do I know about the, I'm sorry, these are side lengths. Oh, side lengths. Side lengths, not angles, but angles would work the same way if they said angles. So I'll put one up here. There we go. So I know they add up to 204. So that's why I say, okay, let's add them up to 204. Solve the equation, and x is 12. So I just need to find the side lengths again, reading the question. So 4x is going to be 4 times 12. 5x is going to be 5 times 12. And I can find the sides of a triangle. You will see questions like this for sides of a triangle, and you can see them like angles like I had originally drawn them. Let's say the angles were in this ratio. How would I find angle measures? Right? Let's say these were the angles. The 4x was an angle, the 5x was an angle, the 8x was an angle. What would I know about the three angles? They add up to an 8, solve for x that way. So depending on what you know, we just kind of set them up. So let's try the next thing. How awesome is this? Let's see. Proportions. Okay, so we should be familiar with proportions. Two ratios are equal. That's a proportion. So here's an example. A over B equals C over D. The denominators can't be 0, so that's what that little note is. We have these words means and extremes. So when you look at a proportion, the extremes, and if I write it a different way, here we go, A, B to C, D. A's to B equals C equals to D. That's another way to write A over B equals C over D. Do we agree about that? Those two things? They're equivalent? The extremes are the outside ones, the A and the D. Those are my extremes. The means are the inside one. And we have a rule that the product of the extremes equals the product of the means. You may know this as the cross product property. Cross product property. And here's how it works. In a proportion, the product of the extremes equals the product of the means. So A times D equals B times C. Familiar, anybody? We did this in Algebra 1. There should be, yes, of course. 3 hands. Awesome. Okay? So cross product property. Now, you may have learned it even before algebra. I don't know how this works. Something about is over of or something. Did anybody get some kind of little trick on how to do them? Good job. Yeah. Well, how does it go?
Is over equals x over 100.
Yeah, right. Okay, no. Product of the means equals product of the extremes. You're doing a cross product. So I can't write, so I can't prove it. But you know how you prove it? how would I solve this equation to get rid of denominators? I just want to get rid of denominators in the equation. How would I do it? Well, I don't know how to cross multiply. I'm trying to prove you can. So, can't I just multiply both sides by b? Let's see if I can do this here. If I multiply both sides by b, what does that do to this one? If I'm multiplying here, what happens to these two? They're gone, right? So I have a equals c times b over d. Now if I multiply both sides by d, what's that going to do for me? Oh, goodness gracious. All right, I'm multiplying both sides by d now. What happens? This d crosses out. What am I left with? AD. This works better when I can write. Equals, the d's are gone, BC. Is that the cross products? AD equals BC? So I'm really just, I'm doing that manipulation and remembering that that's how it works. So that's a cross product property. How can that help me? The perimeter of a rectangle is 484, and perimeter is distance all the way around. The ratio of length to width is 9 to 2. Find the area. Now we're looking for area. Let's see. Area. Area. We'll try this. Oops. Okay. So how am I going to do that? Any ideas how we can kind of work this problem out? And I've got my picture to help you, and always draw a picture. If it didn't come with a picture, you're going to make one. So 2 to 9, here is my ratio. I don't know what the actual side is, so the x is kind of taking that place. So what do you think, Michelle? Yes, yes. Because since it's a rectangle, what's the length of this side? 2x. And what's the length of that side? 9x. So 2x plus 9x plus 2x plus 9x is going to equal that 484. So I've got some of this up here already. So perimeter is twice the length times twice the width. So 484 twice the length times twice the width. And then I just do a little solving of an equation. I'm getting x equals 22. So the length is this, 198, and the width is that. So how do I find area? Area is length times width. So now I can just multiply those two things. Yes? What? I'm sorry, say it again. We're supposed to find the area. If the sheet says perimeter, yes, cross that out. I want to find the area because I know the perimeter. Perimeter is 484. So this is kind of a multi-step idea of finding x and then using those values to find something else. You could have also said 2x times 9x equals what? And then once you know x, you could plug it in there, and you get the same kind of thing. See another example here. The measure of the angles of a triangle are in the ratio of 1 to 2 to 3. Find the measures of the angles. So again, you set it up. Here's 1x, 2x's, 3x's. What do the angles all add up to? What? 180 is what I'm looking for here. Right? So you add all these up and you set them equal to 180. Find x is 30. Then read the question. I want to find what the angles are. So this angle is just x. This one is twice x, and that one is 3x. As a really good check, what's a really good check when you're all done? What should you do? Yeah. Yeah, add them up. Add up 30, add up 60, add up 90. Make sure it adds up to 180 just to find some kind of arithmetic error somewhere. Definitely do that. But they do. They add up to 180. Nice examples here. Solve this. Yeah. How do we solve that proportion? How do you solve it? Well, let's do it. Here it is. Okay, I don't want to do that. Use cross products. And there's a reason why I want you to get rid of that one step which they taught you. It's multiply and divide like all in one step, right? You learned that prior to Algebra 1. I know that. But let's write it out. 10x equals the 15 times the 16, and then solve that. Because it'll help us when we get to other ones. What? 5. 5 times 16, 90, right? It looks like 90 to me. So what's x? It's not 90. 16 times, yeah.
9? 80? Use the cross products. Don't take any shortcuts, because when we get harder ones like this, we can't really use the shortcut. So I want to make sure we know what we're doing. This times this equals that times that. Let's see, I have this one here. I can put it up. Okay. So 3y times 1 equals twice y plus 1. Are these parentheses important? You betcha. Why do I have to make sure that these were grouped in parentheses? Why? Yeah, right, that whole thing is getting divided by 2. What gets multiplied by 2? Everything. So make these parentheses are critical. You leave them out. You're not doing this correctly. I did my distribution here. Subtract the y, so y equals 2. And you can check these. Plug it in. 1 over 2 plus 1 is a third. 2 over 3 times 2 is 2 over 6, which is also a third. I like to check that I got the right y, because I make dumb mistakes all the time, as you know. So use cross products. Whatever shortcut you were using, I want you to stop using it, because I really want you to think about cross products. Now, a geometric mean is something else. You may remember these things. Arithmetic sequences. Anybody remember these? 2, 5, 8, 11, 14, 17. What's coming next? What's coming next in this pattern? We're using inductive reasoning. What's coming? 20. How'd you get that? How'd you get 20? Pattern of adding 3. And we call that the common difference. How do we find the common difference? Well, it's 5 minus 2, 8 minus 5, 11 minus 8. So, yes, indeed, we got 20 here. And our common difference is 3. Now we also had geometric sequences. So how did those work? Now what's coming next here? 2, 6, 18, 54. Well, how are we getting what's coming next? How are you getting what's coming next? We're multiplying by 3. We call that our common factor. How do we find that out? We do 6 divided by 2, 18 divided by 6, 54 by 18, and we get the 162 with our common factor of 3. Remember this at all? Go like this. Thank you. All right, we're nodding up and down. So an arithmetic sequence you're subtracting. With geometric sequences you're dividing. A term between two terms of a geometric sequence is called its geometric mean. Example, if you have a geometric sequence 4, 20, 105, and now what's my common factor? 20 divided by 4, 100 divided by 20, that's 5, right? What would be the next value in the sequence? 500, right? So the geometric mean of 4 and 100 is the number in between. It's 20. We call that a geometric mean. So can we find the geometric mean if you've got 3 on one side and 300 on the other? Yes. How? What is it? 30? How'd you get that? What? Natalie told you. How'd you get it, Natalie? She just said it came to her in a cloud, in a dream. How do you get that? Multiply by 10. Does that work? So 3 times 10, let's see, let's put in the 30 and see if that works. And then 30 times 10. We getting it? Does it work? Well, how do you get that? Let's see if we can maybe find a more orderly way. If you have an A on one side and a B on the other, how do we find what goes in that middle? Let's see here. So I've got A and B. I don't know what it is. Let's put an X there, right? Now, what do I know about this, the common factor, right? This divided by this is the same as that divided by that. So I created a little proportion. B divided by X equals X divided by A. B over X equals X times A. Makes sense. First, we got to believe that. Do we believe that? Oh, sure. All right. Now I'm going to use a cross product. So X times X is what? X squared equals A times B. How do I find X? Take the square root of both sides. So I get X equals the square root of AB. Did that work for this one? So if I take the square root of 3 times 300, what's 3 times 300? 900. What's the square root of 900? 30. Look at that. Now she knows how she got it. She did that in her head. So that's called a geometric mean. How do we find it? If you have two positive numbers, A and B, positive, right? The positive number x, that satisfies x equals the square root of AB. So you're going to multiply the two numbers and take the square root. That's how you find the geometric mean. I like doing this little sneak peek for my my advanced students who want to go far in math. Remember arithmetic means? Remember that?
No.
What do you mean no? Arithmetic mean. What does this mean here? This says you take the sum as I goes from 1 to n of x sub I. So we're adding up members of a data set, n members of a data set, and we're dividing by n. Add up n numbers, divide by n. Oh, please, we did this in algebra last year, right? Yes, she remembers. Who remembers? Yeah, you better want to do this again. Because guess what happens as you get into higher math, not only do you add stuff together, you can also multiply stuff together. This is what this uppercase pi does for you. An uppercase pi is a multiplier. So to find geometric means, you are going to multiply n numbers and take the nth root. How awesome. Now, what are we doing? We're doing the geometric mean of two numbers. N is 2. So you're going to multiply two numbers and take its square root. That's as far as we're going. But you can take a geometric mean of n numbers, more than two numbers, just like you can take an arithmetic mean of more than that. Cool. I think it's cool. All right, so go ahead. You do this. Find the geometric mean of 2 and 8, and then find the geometric mean of 24 and 48. Using that new formula now. Don't come in cloud. Remember that dream where it came to us before. You multiply the two numbers, take the square root. If it's not a perfect square, give it to me in simplest radical form. Go ahead and give that a try. How'd this go? How'd this go? Now, did we get A with little to no difficulty, I hope? Right? You're going to multiply the two numbers. 2 times 8, you get 16. You take the square root of 16. I want the positive root here. So 4. So who got A? Awesome. Most people. All right, now B, same kind of thing. You're going to take 24 times 48, and you're going to multiply, take the square root of that. So simplest radical form, because this is not going to be a perfect square. Now, I noticed that 48 is 24 times 2. So I had 24 times 24 times 2. So isn't this one that can come out? What's the square root of 24 times 24 is 24? And a square root of 2 came out. So this is simplest radical form. Remember that? 3 hands. Right? Simplest radical form means that, if there are already perfect squares, they come out, and stuff that isn't stays in. If you do this to the nearest hundred, say, sometimes they want an approximation. You just type it into your calculator. I think it's about 33.94, something like that. So yeah, so we have the old skills. The old skills are coming back to haunt us. But that's how you find the geometric mean. Geometric mean, awesome. Let's see what we got here. Proportion properties. There's fun things you can do with proportions once you get that the product of the means equals the product of the extremes. If two ratios are equal, then their reciprocals are equal. How come? So here's AB equals C over D. I'm claiming B over A equals D over C. How come I can say that? How come? Exactly. If you look at cross products, A times D equals B times C. Is that still true? A times D equals B times C. As long as your cross products are still true, you have an equivalent of proportion. What else do we know? If you interchange the means of a proportion, now remember, these are the means. If you just swap them, so B goes up here and C goes down here, that's what I did here, you have another true proportion. How come? Why is that still true? Michelle, why is that still true? Because that looked like a hand up to me. Why? Well, why was this one still true? Why was the first one still true? Oh, we don't know. Why was the first one still true? Isn't this times this still the same as this times this? BC equals AD. BC equals AD. Look what's going on here. BC equals AD. As long as the cross products are the same, it's an equivalent proportion. What else could I swap? You could swap the extremes as well if you want to. Put the D here, put the A here. It's still going to be an equivalent proportion. This one's a little wild at first. So in a proportion, if you add the value of the denominator to the numerator, then you form another true proportion. What? How come? Look what I did here. I had A over B, and I said A plus B. And I had C over D, and I said C plus D. And I'm claiming they're still equal. Yeah, how come?
So usually these cancel out and then you have to bring back to 4.
How are they canceling out? You're so on the right track. How are they canceling out?
B divided by B is 1.
Yes.
And 1 divided by B is 1.
Right, so what do I really have here? A over B plus 1 equals C over D plus 1. If I add 1 to both sides of an equation, what do I know? What about the equation? Still true, right? That's the addition property of equality. If you add 1 to an equation on both sides, it's still equal. That's all I did here was I added 1. So there's other ways you can look at proportions and still have them true. So let's look at some of these here. So if A over X equals B over 5, what is A over B going to be equal to? Well, what am I looking for here? First of all, what happened here? I moved that B over here. So what would be an equivalent statement? What could I do with the X? Move that up here and I get X over 5, which it's hard to type that. But X over 5, how come? Look again at the product of the means and the product of the streams. 5A equals BX. This one's a little hard to see. My 5's on the bottom. 5A equals BX. It's just, I want you to start seeing these a little bit quicker without having to think so hard, using those little rules. Let's look at this one. If X over 3 equals 9 over Y, X plus 3 over 3 equals what? That kind of new rule we had. When's it going to be? 12 over Y? Is that right? What's it going to be on? 9 plus Y over Y. You add the denominator, because remember I'm adding 1. So if you have 9 plus Y, there's a plus Y over here. Oh, okay, let's try it. See how that's 9 over Y plus 1? That's X over 3 plus 1. So you add the denominator. What's going on here? True or false? If X over Y equals 10 over 7, then Y over X equals 7 over 10. True or false? Yep. True? How come? How can you tell? Yeah, exactly. I still have the same cross product. 7x equals 10y, 7x equals 10y. This is true. How about this one? If x over y equals 10 over 7, then 7 over x equals y over 10. Is that true or false? What is that one, true or false? And how can we tell? I'm worried about the blank stares. Cross products, that's your key. Look at the cross products of the first one. What's the cross product of that first proportion? Yeah? Right, let's turn it around to 7x equals 10y. We always put the number first, right? What about the other side? What am I getting? Yeah. Exactly. The cross products are not the same. This one is 7x equals 10y. This one is xy equals 70. This one's going to be false. Let's see if these come up. Yeah. So we have to kind of look for that cross product. It's going to be the key to these kinds of questions. Some examples of proportions. In the diagram below, RU to US equals RV to VT. Find x. So you're just going to basically set up a proportion here. Let's see if I can do that. Again, without fractions, it's a little hard. But RU is 5 over x, right? What's that going to equal RV over 8? So now we want to use our cross products, which is product of the means equals the product of the extremes. So I'm written this way. Maybe we can see it a little better. 5 times 8 equals x times 20. Right? Right? So I'm getting 20x equals 40. So x equals 2. And I guess that's all I need to do here. It just said find x. These are ones you really got to check what the question is. Sometimes they'll say find rs. Right? So you need to kind of really be careful what it's asking. In this diagram, let's see, what are we doing here? RU is to US. RU. Ooh, what's RU? They're not explicitly giving me RU. I'm getting RS, and I have SU. So what's this little piece? And think about the segment addition postulate. What's this little piece going to be here? If this plus this equals x, what is this little piece in terms of x? Yeah? X minus 4. So now I've got x minus 4. I think I'll put it in parentheses because I'm writing fractions in a wacky way. To US equals RV 3 to VT, which is 6. So set up your proportion. So what do I have here? Product of the means, 6 times x minus 4 equals, that was the extremes actually, the means. 4 times 3 is 12. That means x minus 4 equals 2, so x equals 6. Yes? I just divided by 6 first. If you want to distribute, you could. That's fine too. But you can find them. And again, read questions carefully because maybe they want you to find, well, what is RU? What is RU too? So you have to read the question carefully. What else do we have here? Some more examples. For my own sanity, you're going to try these. Because these are the U-tries. I'm turning them into U-tries because it's hard to do these at the same time, and I think you have enough information. Some of us are kind of done here. Let's see how we compare. How'd I do? Am I correct? Sometimes I'm wrong, so, you know, that's why I'm having you guys check me. How would we do with G? Setting that guy up, right? Some of you did a real nice job realizing that JM is to ML. Well, they're not giving me JM, but ML is 10. This whole thing is X. So JM is going to be X minus 10, and that compares to the 10. And that's the same as KN to 15. And then I hope we did product of the means equals product of the extremes. I got X to be 22. Is that right? So let's see. So that's why JL is 22. And then what else do they want us to find? JM would be 10 less than that. So that's where that came from. This one, you just set up the proportion. 9 inches is to 36 miles, and then reduce. We always reduce. Usually it's 1 inch to something. It's kind of how we do it with maps. So try to make that a 1 inch if you can, even if that makes this some kind of fraction or decimal. So what do we think? It was a tough lesson because of the messed up board here, but I hope we got through it okay. Let's take a look at homework and the assignment that's coming up.